Hi everyone, and welcome to part 2 of the Functions and Macros lecture. In part 1, we talked about a review of functions and why you might use functions versus macros. We're going to jump into part 2 and talk about the different types of macros and a couple more use cases for macros. So macros are used to define constants. That's the simplest type of macro. They can also be used to perform simple functions, like we saw in part 1 with the square function. Macros are basically text replaced, so anytime you have a certain word or a certain sequence of letters, they're going to get replaced with whatever comes after them when you define it. Macros, again, work for all data types, and you don't have to specify your argument type or your data type for your variables or your return type. There are two main types of macros. We have object-like macros and function-like macros. So let's talk about object-like macros first. These are by far the most common, and you've actually seen some of these up to this point. Basically, this is a constant definition. In ZUI books, sometimes the book will define something as a constant int. This is basically a good replacement for that, and you define it outside of a function, so you don't even have to worry. You can use it in any function you want. This is the syntax. So we have # or a hashtag define. The name is usually written in all caps, a space, and then whatever we want to replace that name with, so some value. There's no semicolon and there's no equal sign. Again, we talked about that in part 1. There's no semicolon and no equal sign because it's going to replace whatever comes after this name. Everything here is going to just get copied and pasted down. So if you have an equal sign or you have a semicolon, that's going to get copied and pasted down with it, and it's going to end poorly. Right? So let's look at an example. If I define n as 10, what I'm actually defining n as is = space 10. So anytime it sees n, my preprocessor is going to come down and it's going to replace n with = space 10. And if I get this and I actually run this, right? My preprocessor is doing this work for me and I run that, it's going to give me an error in this line. Right? We don't want that. We just want to replace it with the value. You can also use an object-like macro with something a little more complex than just a regular old constant. You can use a built-in math function even. So I could replace pi, right? I can call it old pi with the arctan, 4 times the arctan of 1. You can use other functions or even some complex math to just replace one number, as long as it's still just one number. Object-like macros can also aid in readability and troubleshooting. So let's say I'm writing some machine code, for example. I may want to use on and off as a macro, so that when someone's reading my code, they understand what I mean by 1. So if I use on as 1 and off as 0, anytime I see on, my compiler knows it's just going to be 1, but someone reading my code can understand what I'm actually meaning here. I mean, oh, this switch is going to be on. Same thing with true and false. If you're doing Boolean things in logic, you can replace true, right, the entire value true, with 1 and false with 0. And again, this just helps aid in readability. Now we also have function-like macros. These can mimic very simple functions. We can't do super complicated functions, but very simple functions can be done simply with macros. They're extremely flexible because we don't have to tell it what data types we're going to use. Remember though, to use the liberal use of parentheses, but you must always have parentheses around each individual variable. Now why? Because I could actually plug in some addition as the variable itself. So parentheses are required around each individual argument so that you can replace it with addition or subtraction or something a little more complex. So if I were to call this macro and use it in my actual file, I would use mult, and then x is going to be replaced with a+3 and y is going to be replaced with b. In order to do this correctly, right, I need these parentheses around a+3, otherwise I'll get a different number. You can also use different functions inside your macro. Let's say I want to multiply the results of function 1 and function 2. Well, I can just use function 1 and function 2 inside my macro. So whatever function 2 returns will go here, whatever function 1 returns will go here. and then they'll get multiplied with my macro and they'll get stored in X. Right? That's what that will look like to your compiler when it actually runs it. In fact, any valid C code can be part of a macro, which also means you can have macros inside of macros. If you have really long macros, you have a bunch of math you have to do, you can use a backslash, and that basically says continued on next line. So let's look at an example. If I have this really long macro and it's going to end up being too long, what I can do, get to a good stopping point, put the backslash, and that tells my computer, hey, everything on the next line is included too. So it will include this POW C 2.0, just like it's right here. Macros within macros. This is actually more common than you might think, because you can use object-like macros inside of your function-like macros, as well as other places in your code. Typically, when you define these different types of macros, they're going to be defined in the order that they're used. So let's look at an example. I have a really simple object-like macro. I've just defined nmax as 1,000. You'll see this, and you probably have seen it in some of the PowerPoints on arrays. We always defined a maximum value that was really big. I have my next macro, that's scale, right? So this is just simple division, takes one input. And then I have test scale, and that's going to take two inputs, both X and Y. Now inside main, I've defined A as 2, B as 4,000, and I've defined C as my catch. So if I'm going to run test scale A and B, what will C be? Go ahead and pause this video and try and figure it out on your own. Okay, welcome back. Let's talk through this. So we're going to have A is 2.0, so that gets passed here, and B is 4,000, and that gets passed here. So let's look. So A is 2.0, so 2.0 goes here. All right, and B is 4,000, and that goes here. Well, this 4,000 is actually now an input to scale. Okay, so my input's 4,000, so that 4,000 is going to go up here. 4,000 is going to get divided by nmax. Nmax is an object like macro that comes down and says, oh, that's just 1,000. So now I have 4,000 divided by 1,000, I get 4. A was 2, so now I have 2 plus 4.0, and I'm going to get 6.0, right? Remember, we can mix and match data types in macros, and it doesn't matter. Macros can make really nice custom functions when your custom functions are fairly simple. They work for all data types, like we said, and you can even do simple if statements in them. So let's take a look at this. If I have min and max, and both have two inputs, right, X and Y, I can use this very special format here, which I'll talk you through, to get a super simple if statement. What this is saying is if X is less than Y, then X, else Y. So if X is less than Y, return X. If it's not, return Y. Right? You can think about it like this. In this case, my max, if X is less than Y, then Y, else X. So if X is less than Y, return Y, otherwise return X. Okay, so if we have this example here, C equals min AB. This is in main. So now I have A is 2 and B is 3. All right, so it's gonna return, right, because I'm running min, the smaller of A and B. So this is gonna say, okay, A is X, A is 2, B is Y, and B is 3. So if 2 is less than 3, then return 2. So this would return 2 and store it in C, and this would return 3 and store it in D. We alluded to this earlier, but I didn't go through an example. Why are the parentheses so critical, right? Why do we have to put parentheses around each individual variable or each individual input in macros? Let's take a look. So if I have a macro, SQ, it takes one input and it's defined as X times X. I have defined Z, right, with SQ, my macro, of A plus 3. Okay, so now I'm gonna replace x with a plus 3, and I'm gonna get a plus 3 times a plus 3. But because those aren't in parentheses, I'm not gonna get the FOIL method that I actually want, right? I'm gonna get this 3a multiplied and then the additions afterwards, right? If we do the math out on this and we plug in 2 for these a's, we're gonna get 11. That's probably not what we wanted. We wanted a squared plus 3a plus 9, right? In order to fix this, we have to put these parentheses around those x's. Some other pitfalls we see with macros. The compiler sees the code after the preprocessor, right? So after it's built. Because of that, any errors that are in your macro will show up in the line where they're used. No errors will ever show up in the line where the macro is defined. So if you start to see errors in lines where macros are used, go check your macro line. A lot of times you'll get this weird error, right? It'll say like, oh, need a semicolon or an extra equal sign or something. And you're like, but I don't have a semicolon and I don't have an extra equal sign. If your error doesn't make sense, go check your macro because it's probably there. What can be done to try and limit this? Remember, use those liberal use of parentheses, but make sure you use them around each individual variable. No equal sign, no semicolon. Those are the big ones. Make sure you build first, then compile. Don't run and build and run at the same time. That will also help. Okay, let's look at this one. This is the error you're gonna get if you run this code. Do you see what's wrong with it? Pause and check. Right? How is my error in line 8? That's this line here. Well, if you look, we put a semicolon on the end of this line. And what that resulted in is this weird extra parenthesis. And if you go back to what the error actually is, it says line 8, function call is missing a parenthesis in function main. That happened because we ended this line and then we just have this one open parenthesis and that's another line. Our compiler doesn't know what to do with that, so it gives us an error. So remember, if you get an error inside the line with the macro in it, go up to where you defined your macro and check it. All right, we fix that simply by removing the semicolon. Just some reminders on macros, common things to avoid. Those parentheses, that semicolon and equal sign. Your compiler doesn't see the macro. Remember, it gets replaced before your compiler actually runs it. So if you get an error, go check the macro line. There'll never be an error in the macro line. All right, so small functions can be written as macros. This can save some processing time and also some space inside of your code itself. Preprocessors are commands your compiler never sees, right? They're just replaced, and they can aid in readability and understanding and troubleshooting. Conventionally, all macros should be defined in all caps. Now, it will work if they aren't defined in all caps, but they definitely should be. That's a stylistic thing. Remember, if you use macros, double check. They should be written very carefully and check for those parentheses for inputs, check for that semicolon, and check for that equal sign. And that wraps up part 2 of the Functions and Macros lecture. Again, I'm Professor Casey. Thank you for joining me today. If you do have any questions, feel free to reach out to me via email or leave a comment below. I do check them frequently. Have a great day.